So today we'll be looking at implicit differentiation. So implicit differentiation, it will be like deriving x and y both at the same equation. So an example of that is, let's do a quick example so you can understand what I mean by implicit differentiation. Let's say we have a function. Let's say we have an equation where they say must find dy over dx. Yeah? Given that y to the third plus x to the third minus 5y minus 4x is equal to 9. Yeah? So to solve this, to derive this equation, we'll be required to use implicit differentiation. Reason because on the same equation we have y and x. Okay. So how do we do it? So first thing to remember is that when we derive y, we have to multiply it with dy over dx. But then when we derive x, we don't. This is because we are deriving in terms of x. Okay, this is what I mean. So how do we derive y to the power 3? So y to the power 3 is just simple power rule. So y to the power 3 will be using power rule. No? So what is power rule? Power rule is saying if you have a function where you want to derive x to the power n, the derivative will be n multiplied by x to the power n minus 1. No? So from y to the power 3, what will be our n? Our n will be 3 because it's our power. So this means that we'll take the 3, multiply in front, or multiply y. So this means we'll be having 3y. Yeah? And then power rule says we have to subtract 1 from n. So when we subtract 1 from 3, we are left with 2. Yeah? So as I was saying that, if you derive y implicit, you have to multiply by dy over dx. But then when you derive x, you do not have to do that. Okay, so we'll say plus. So how do we derive x to the power 3? Same power rule. You know this will be 3x to the second. Yeah? This is x, so we do not have to multiply by dy over dx. And then we come to negative 5y. How to derive 5y? So the derivative of y becomes 1. So the derivative of negative 5y will be negative 5. But because we are doing implicit, we multiply by dy over dx. And then we are left with negative 4x. And how do we derive it? It will be negative 4. Because the derivative of x is 1. Which will be equal to the derivative of a constant in terms of x becomes 0. Okay. So now we have an equation like that. So what is the next step? The next step is putting the like terms together. We can take 3y to the second multiply by dy over dx. We bring negative 5 multiply by dy over dx, which will be equal to, we take 3x squared to the other side, which becomes negative 3x squared. And then we take negative 4 to the other side, which becomes positive 4. So now we can factorize. So dy over dx will factor out. We'll be left with 3y to the second. We factor out, we'll be left with minus 5, which will be equal to negative 3x squared plus 4. So now we can take this to the other side. So we'll be left with dy over dx will be equal to negative 3x squared plus 4 over 3y to the power second minus 5. So this will be our final answer. Okay, so now we can take another example to elaborate how implicit differentiation works. So let's say number B, let's say they say we must find dy over dx if a function is x to the cube plus y to the cube, which is 6xy. Yeah? Same thing, power. We have x to the cube, power rule, y to the cube, power rule, and then 6xy. That's where we get things are like interesting. Yeah, we'll get there. Okay, let's start with x to the cube. So because we're doing implicit in terms of x, we don't have to multiply with dy over dx. So we can use power rule, where we know x to the cube will be 3x to the second. This will be our answer. And then 4y cube, so plus 3y to the second multiply by dy over dx, because we are differentiating implicit in terms of x, will be equal to 6xy. So how do we differentiate 6xy? Okay, so now we have x and y multiplying each other. Okay, so we can start with one variable and then do the other variable. Okay, let's start with x. So if we are deriving in terms of x for x, this becomes constant. These two, they become constant. So derivative of x becomes 1. So what will you be left with? You'll be left with 6y. The derivative of x, it's 1. These two are constant. So you'll be left with 6y. Yeah? And then you add. So now you are deriving y in terms of x, but implicit. So these two, they become constant. So what is the derivative of y in terms of x? It becomes 1. So you'll be left with your constant, which are 6x. But because you are deriving in terms of, you are deriving y, you have to multiply with dy over dx. You see? We first start with x, where we got 6y, because x becomes 1, and then we do the other one, which becomes 6x because y is 1. Yeah? Okay. So now we can just put like terms together. So we can say 3y to the second multiply by dy over dx. We take this to the other side. We get negative 6x multiply by dy over dx. We take this to the other side, which will be equal to negative 3x to the second. And then we have this, which becomes plus 6y. So now we have to factor out dy over dx. So we can say dy over dx will be equal to 3y to the second here minus 6x here, which will be equal to negative 3x squared plus 6y. Now you just have to take this to the other side. So dy over dx will be equal to negative 3x to the second plus 6y over 3y to the second minus 6x. That is our final answer. Okay. The third example that we will do, let's say equation, let's say number C, we have to find dy over dx if we have a function where cot of y is equal to x minus root y. Yeah? So we do the same thing. We derive both sides. So we'll start with this side. So the derivative of cot y will take them from the tables, or you will cram them however you know them. But I'll also post the table of the derivatives. So the derivative of cot y, we will get negative cosecant squared of y. Derivative of cot from the table, it's negative cosecant squared of y. No? But because we are deriving implicit and we are deriving y, we also have to multiply with dy over dx equal to derivative of x in terms of x, it will become 1. Simple. And then now we come to derivative of root y. So we can change the form in which root y is written. We can change the form into negative y to the power half, because root y is the same as root to the power half. So in this form, let's derive this one. We can say 1 minus, we can say, what is the derivative of y to the power half? We use the power rule. How? We know, for the power rule, n has to multiply in the front of y. So we'll have half to the power y, and then half also we must also subtract 1 from half. So half minus 1 will become negative half. You see? So this is the whole equation, negative cosecant square of y multiply by dy over dx will be equal to 1 minus half y to the power negative half. But look here, because we are deriving y implicit, we also have to multiply dy over dx. Don't forget that. Yeah. So now we can group the like terms. So we can say negative cosecant square of y multiply by dy of dx. We take this to the other side. Because it's negative, it becomes positive half y to the power negative half multiply by dy of dx is equal to 1. Now we factorize out dy of dx into negative cosecant square of y, yes, and then we say plus half y to the power minus half. It's this. To be equal to 1. Yeah? Now we have to take this to the other side. So dy of dx be equal to 1 over negative cosecant square of y plus. No? Here we can return half y to the power negative half to its original form. In this way, we know half y to the power negative half. To return it to its original form, it will be half multiply 1. Because it's negative, it's going down. 1 over the root of y. Multiply these two, we have 1 over 2 root of y. Okay, take this, we'll put it here. See? 1 over 2 root y. No? Okay. So this can be our final answer. So to simplify this further, we can say dy over dx will be equal to, let's try to simplify this one. 1 over, so because we have 2 root y in the denominator here, we can make it like our common denominator because we want to simplify. So we can say over 2 root y. And then when you make it your common denominator, you have to multiply here where you don't have it. So we'll say, because there's negative 2 root y multiplied by cosecant square of y plus 1. We don't multiply this side because we have it plus 1. So we can simplify it more further by saying dy of dx will be equal to. So when you have an equation like this, it simply means 1 over 1 multiplied by, this will be at the top 2 root y over negative 2 root y cosecant squared of y plus 1. So multiply, this becomes at the top. So this will be 2 root y over, denominator will be this, but because this is negative, we can start with the positive. We'll say 1 minus 2 root y cosecant squared of y. So that is our final answer.